Alright, so these are the notes for 8.7 radical functions. And our goal is that we want to graph radical functions and we want to look at the transformations and describe the transformations by changing the parameters. Okay. What is a radical function? A radical function is a function whose rule is a radical or has a radical expression. So you'll see those like square root type symbols are actually radical symbols, and it could be to the third root, fourth root, or even just the square root. A square root function is just that, involving the square root of x. So that's the one we'll be mostly working with, but you could see others. Now, you should take note that when you look at this, this is technically the opposite of x squared. But if you just did the square root of x on the calculator, this is all you would see. That graph that starts at 0 and goes up. So it doesn't finish. It's a discontinuous function. To see, like, I guess the whole opposite of square root of x, or x squared, you'd have to do also the negative square root of x and see how that would finish that out. So you can see how that's totally the opposite of x, the quadratic, which is x squared. Again, not something we would worry too much about, but you can kind of see that. Okay, be expected to also identify the domain and range of these functions. So I would look at the graph and then kind of tell me, like in this case, we see the f of x equal to the square root of x, and you can see that since it's starting at 0 and it's going to the right, all the x's, x can be any number that is greater than 0. The range, starting at 0 and it's going up, even though it looks like it's balancing out, it's still technically always going up. So y is any number that's greater than or equal to 0. So that would be a little bit different than, say, something that might be like something like this, where if I started here and went like that, okay, then I would say here the domain is x greater than or equal to -2, because that's where it's starting at. But the y, the range, is still going from 0 up. So y is greater than or equal to 0. So keep in mind that you might have some domain and range problems there to ask, and that's something to be prepared for. Okay, so let's look at one more example there. Here, f of x is equal to the 4 times the cube root of x plus 4. And if you look at it, this is what the graph would look like. So if you look at the graph, there is no limit to, it's a continuous function, so there's no limit. It's going all the way to the left, it's all the way to the right. So we're going to say that x is a member of all reals. That's the terminology I'm going to use. And you notice y is the same thing, because it's going up and it's going down. There's no stopping it. So x and y are just members of all reals. We used to say this like saying negative infinity and positive infinity, but I'm trying to get you more used to what you're going to see with, say, other classes and other tests. Okay, so now let's look at the transformations, and I'm going to actually give you quite a few examples on transformations. We've done this before, but now we're dealing with the radical symbol. This right here is a minus, and we're now going to also deal with the plus and minus on the reflection over the x-axis, because there is a difference in this one with the reflection over x and reflection over the y. And you'll actually see that in one of the other examples in a little bit. But again, as before, the a determines your vertical stretch. The reciprocal of this 1 over b will determine your horizontal stretch or compression. Plus h moves to the left, minus h moves to the right, plus k moves up, minus k moves down. Okay, so we've got to remember those rules. That's something that you should add to your note card. Okay, so here's an example. F of x is equal to the square root of x. G of x is equal to 2 square root of x plus 3. Describe the transformations from f of x to g of x. Well, because of the 2, I can say, and that's in front of everything, that would be a vertical stretch because the number got bigger. It got bigger from the 1 that's in front of the square root of x to 2. Okay. Then the plus 3 means I'm going 3 to the left. So keep that in mind. So that one was vertical stretch by 2 and 3 to the left. Okay, on the next one here we have f of x is equal to square root of x. My parent function, g of x, is equal to the square root of negative x minus 2. Now because of the negative, this is a reflection, because remember it's in the front, but because it's a reflection inside the square root symbol, the radical symbol, that means it's a reflection over the y-axis. And I'll show you an example of why that's important. The minus 2 moves it down 2. Now, let me show you why. Parent function here is f of x, or the square root of x, sorry. If I do negative square root of x, where the negative is on the outside, that's a reflection over the x-axis, so it would look something like that. But when I do a negative square root inside this square root symbol, or square root of a negative number, then notice how that changes the direction. So this one I will put in reflections over the y-axis, and you have to make sure you're careful with that, because there is a difference between those graphs. Okay, 2 more examples and then I should be done. Okay, so here's my f of x and then here's my g of x. The negative means it's a reflection. Since it's out in front of the square root, that would be a reflection over the x-axis. Okay, the 3 represents a vertical stretch, and the minus 1, since it's outside the square root symbol, would mean go down 1. Okay, so there's that one. And again, if you break them down like that, that should make it a lot easier. So here's my f of x, square root of x. My g of x is 2, square root of 1/3, parentheses x minus 4 plus 2. Okay, I'm trying to put in all the examples here on this one. The 2 in the very front means that's a vertical stretch because that's a bigger number, or it got, it grew. So there's a vertical stretch by 2, or we can just say vertical stretch. The 1/3, remember, inside the square root symbol, you should always think opposite. So the opposite of 1/3 is actually 3. And that means that's a horizontal. And since, again, it's a bigger number, stretch by 3. Although I'm not too worried about how much by. The minus 4 means you are going to go to the right 4. And then the plus 2 is up 2. So that covers transformations, and again, this is stuff that you've seen before, just a little bit added to it. That should make it fairly easy. That's 8-7. What I'm concerned about in a nutshell. Should not be too difficult, and that's that. And I will see those notes. I'll check them the next day. Thank you.